So this lecture is going to be about mediation. Now, mediation is a special form of regression that helps us to understand causal processes. Now, remember, we can't infer cause and effect from correlational data, but we still have questions about causal processes, right? Even when we collect correlational data. So mediation allows us to investigate those processes even when we just have that data. Of course, if you do it with longitudinal data, it's even better. But we can also do it with correlational data. So some of the research questions you answer with mediation are: what is the process or mechanism through which an effect occurs? And what variables explain variance in a relationship between X and Y? So that's the more generic version of mediation. So we've been working with two types of variables, right? Our X variables are predictor variables, our independent variables, and our Y variables are dependent variables, our outcome variables. Now we're adding a new variable, which is another type of independent variable, but we call it a mediator because we're expecting it to be between our first independent variable and our dependent variable. And then what we get when we include this mediator is a new effect called an indirect effect. So the indirect effect is how much is X's, or the predictor's effect on Y, on the outcome, attributable to this mediator. We can get an estimate of this effect, so an actual number associated with it, and test whether it is statistically significant. All right, so let me give you a couple examples of mediation types of questions. So in this analysis, the researcher was interested in whether investing in talent created a more positive business result, right? So here's our talent investment, here's our business result, and they wanted to see if that was due to the fact that their talent became more developed, right? You would think that if you put a lot of people into these workshops where they're learning new skills, then their increase in their skills would be what is causing their business to become better. So you can test that in a mediation model. Here's a much more complex type of question with multiple mediators at different levels. So you call them mediators. These are sort of more distal mediators, and there's the more proximal mediators. So this is looking at the effect of education level on women's numbers of births, right? And so there's several ways that your education level could influence how many births you have, right? One is the fact that, well, maybe if you are more educated, then there are more people in your social network who have fewer children, and that is influencing how many children you decide to have. You can also think about, what your level of education is. You have lower education level, you might not know so much about different types of contraceptives that you could use, which would mean that you don't use those contraceptives as much, and therefore you have more children, right? So with mediation analysis, you can test these types of paths, right, with just correlational data or with experimental or longitudinal data. And you can also include these sort of multiple pathways and some more complex analysis that we won't get into this class, but as you can see, it really becomes quite easy to test a lot of different ideas with mediation. So that makes it really powerful. All right, so mediation relies on the same linear model that we've done before, except this time we have two equations. So the first equation is a normal multiple regression with two predictors, X and M. So this is our independent variable, and here's our mediator here, and they're both predicting Y. But now we have an equation for M. M is its own line, it has its own intercept, and its own predictor, which actually turns out to be the independent variable, right? So when we're writing these mediation effects, we use the letters A, B, and C to remember what paths we're talking about. All right, so let's start with A. A is the path between the independent variable and the predictor. B is the path between the mediator and your dependent variable. C is the path between the predictor and the outcome, the independent variable and the dependent variable. And we actually have two different types of C's, right? So just a normal C is the path when you're not controlling for the mediator. The mediator is not in the model. And C prime, the C with the apostrophe after it, is C prime. That's what we're looking at when we include the mediator. All right, so all of these effects are related to each other. And we can actually see that if we add up the direct effect here, which is C prime, plus the indirect effect, which is the path A times path B, then we will get that total effect, which is C, which is independent variable predicting dependent variable without controlling for the mediator. I know it sounds complicated, but you'll see it once we get into some actual output. So here's a mediation example. So this is with microaggressions, which are subtle forms of discrimination where it's more ambiguous if someone is negatively talking about your identity. So this analysis was looking at racial microaggressions and whether they lead to more stress in college students. And so our research question was, are certain coping styles more likely to lead to higher stress when you experience microaggressions? So the hypothesis was that individuals who experience more microaggressions are more stressed because they are more likely to use maladaptive coping styles. Now, notice the way that this is phrased here, right? The first part of that hypothesis is that microaggressions are related to stress, right? And then we're saying it's because of coping style. So that's what puts coping style as the mediator, and that this relationship is explained by this variable. All right, so our independent variables here are racial microaggressions. MA total is the name of that one. We're looking at venting coping style. So venting is what it sounds like, where you go to someone and you just talk about it without trying to resolve the problem, talk about your emotions. And then stress, we use the perceived stress cells. So that's why that's PSS total. Okay, so this is our research question and here's our mediation diagram. How would we run this analysis? There's actually two ways to run a mediation analysis. Okay, so this is the traditional way. This is the way you have probably heard about in many, if you read articles that use mediation before. So the first step, this involves running 3 different models. The first step is to estimate path A, which is the independent variable to the mediator, so right there, right? The second step is to estimate path B from the mediator to your dependent variable. Then you're going to estimate path C, which is the independent variable predicting the dependent variable without the mediator. And then you estimate path C prime, which is the independent variable predicting the dependent variable with the mediator. Unfortunately, you can do one regression that's A, one regression for C, and then one regression that has B and C prime in it. So you don't actually have to run 4, you can just run 3 regressions there. Now, remember we're interested in this indirect effect to say whether the mediation is significant. And in order to look at all this, we have to have A, B, and C must be statistically significant. So P less than 0.05 or whatever alpha level you're using. And then C prime, when you're controlling for the mediator, has to be smaller than C when you're not controlling for the mediator. This leads you to 2 types of mediation. You can have partial or full. It's full mediation if C prime is not statistically significant, right? C is significant, but C prime is not significant. That's full mediation. And then it's partial mediation if C prime is still significant, but it's smaller than C. Whew. So that's quite a bit of conditions that you have for traditional mediation analysis. So let's look at our venting data to see how that would turn out. So first, we have to have path A be statistically significant, and that's less than 0.05, so that is significant. B has to be significant, so that's less than 0.05, that's significant. We see that microaggressions, experiencing more microaggressions is associated with doing more venting, and that more venting is associated with more stress. But we also have to have C, which is microaggressions on stress, or stress on microaggressions without venting. That needs to be significant. And what we see, there is a positive relationship between microaggressions and stress, but it's not statistically significant. So that we stop right there, right? So we have gotten to A, B, and significant, C is not significant, therefore no mediation, right? So that would basically be where we would stop with the traditional way and say, okay, we don't have significant mediation. Even though microaggressions are significantly related to venting and venting is significantly related to stress, venting does not explain the relationship between microaggressions and stress, right? So the traditional way is very strict, right, in terms of making sure that the mediation is happening. There's a newer way, which we'll read about in the Hayes book, that is less strict and actually focuses more on just that indirect effect itself, not so much all those other steps, right? So in the newer way, which is what we're going to focus on running in class, we're going to estimate path A again. We're going to estimate path B. We don't care about path C anymore. We're going to still estimate C prime. But now, for our mediation to be significant, we are just going to look at A times B, which is that indirect effect, and look at the confidence interval for it, right? So we're literally just focusing on A times B and what the confidence interval for that is. We don't actually care whether A, B, and C prime are statistically significant. So let me talk a little bit about what this bootstrap effect is. So you remember confidence intervals, right? What you do with a bootstrap confidence interval is you say, we have this indirect effect. What we're going to do is we're going to estimate that the indirect effect is AB. So we're going to estimate that thousands of times, as many times as you want to do it, right? And then what you do is you create a sample of these indirect effects, right? So you get, 5,000 or 10,000 indirect effects. And then you create an interval, right? So you say, okay, I want 95% of them. And you say, okay, so I have all these indirect effects that I estimated from the same sample that I have. This is not a hypothetical sample like we do in normal hypothesis testing. This is using your same sample, just estimating the same indirect effect over and over and over and over and over again. So what you get a distribution of indirect effects, right? You say, what's the 95, where are 95% of them within? You take those two numbers and you say, okay, how big is this indirect effect? And what you want is for the indirect effect to be greater than 0, right? Because that would suggest that there is in fact something going on with, there's some relationship here, right? So you want it to be bigger than 0. So if your confidence interval does not have 0 in it, then you have 95% of your values are over 0, and that suggests that there is a significant indirect effect. This way of doing it has a lot of benefits. It's less strict, as I already mentioned, compared to the traditional way. It's also good if your sample is really small and not normal, right? Because if we're doing traditional hypothesis tests with p-values, then you actually are relying on that normal assumption of normality quite a bit. Your sample doesn't need to be normal because you're just using that same sample. You're not relying on some hypothetical distribution in the population. And this procedure is automatically done for you in process, and we can get code for it to do it in Stata too. So you don't have to worry about figuring out how to do this bootstrap confidence interval. You can just write a line of code and it'll produce it for you. So let's take a look at how we would run this mediation model in SPSS and in Stata. So if you're going to use the process macro, then it's as easy as putting in your variables. You can't really do this through syntax unless you want to learn, which is in the book if you want to learn it. You can put your dependent variable here, your independent variable, your mediator, and when we have one mediator, we're using model number 4, that's important. And then you put any covariates or control variables in there. In Stata, what we have to do is use a new type of program called, a new type of command called SEM. And this part right here is gonna use the estimates from here to do the bootstrapping, and then it's gonna print that out for you at the end. So let's look at the results from this analysis. So this is the results from process. So process is gonna give you 3 different sections here, right? So our first section is from the first regression that we run for predicting venting. So this is looking at microaggressions on venting, controlling for all our covariates, right? And you get that point of, this is just the same as any regression. You're going to get your overall model, and then you're going to get all your slopes. What we really care about is just that path A, which is microaggressions predicting venting, so that's 0.02. Then we can look at path B, which is going to be in our second regression where we're predicting stress. Again, we get an overall model and we get slopes and intercept, but we're really just interested in the slope of B, which is venting, predicting stress, and then C prime, which is microaggressions, predicting stress when we're controlling for venting. Right. Okay, we can also call C prime our direct effect, And you're going to see it once again when you get to our third section, where we have the direct effect here. So this is always going to be just exactly whatever C prime was. And now process has calculated your indirect effect for you. And the indirect effect is A times B, path A times path B. So that's what that's how you get this number. The total effect is just C prime plus the indirect effect, A times B. So that's up here. But what we're really interested in is this bootstrap confidence interval for our indirect effect. Now here you can cheat a little bit. This bootstrap confidence interval is right at 0, right? So you can decide whether you're liberal or not to determine whether that is significant, but we would call this indirect effect. Probably not significant if we're being conservative, because 0 is right at the lower bound of that confidence interval. So even though we had a lot of different, the traditional way, we have to test all these different things and significance and compare the size of these, right? We got fairly similar results, right? In fact, these numbers are all exactly the same. It's just more about how we're interpreting the numbers. Now we don't care, in a newer way, we don't care about the significance of A and B or even the direct effect itself. We're just looking at that confidence interval for the indirect effect. All right, so just quickly, here's how you would write that up, right? You talk about your overall thing, what you're doing, and using bootstrap confidence intervals. You would say what path A is, what path B is, what path C prime is, and then you talk about that indirect effect and the bootstrap confidence interval. And since we're using that bootstrap confidence interval to determine whether the mediation is significant or not, if it does not contain 0, significant mediator. If it does contain 0, not a significant mediator. All right, and so that's how you do a mediation. So just to sum up, mediation is really this way of seeing how the relationship between two variables depends on a third variable. We can use it to answer causal processes, and there's two ways that people have done it, the traditional way, and now we're learning this newer way. Both of them are focused on what is the relationship between your independent variable, your mediator, and your dependent